So, welcome to this class on Neuroscience of Human Movement. So, this is part 5 of the discussion on primary motor cortex. Today's class we will exclusively be focusing on the work of Peter Strick, where a group of neurons called as a corticomotor neurons. What are these? We will have to discuss what this is. These innervate different arm muscles through divergent projections with spinal neurons. So, first let us discuss what is corticomotor neurons. Those that have monosynaptic projections with spinal motor neurons are called as corticomotor neurons. These are also called as upper motor neurons. There is going to be a discussion later, but let us at least define this. Corticomotor neurons are those that have connections with motor neurons of the spinal cord or the spinal motor neurons, right. Now, if you look at the evolution of these from mammals to primates to humans, right. In mammals these are present in less quantity. So, there are very less number of corticomotor neurons in lower mammals such as rats, mice, etc. So, that means spinal motor neurons are receiving inputs from the cortex through interneurons in the lower animals. In primates this number increases. In primates, for example in macaques, there is a substantial number of motor neurons in the primary motor cortex that project directly to the alpha motor neuronal pools in the spinal cord, right. So, these are especially devoted to the distal upper limb function. So, or in other words wrist, finger functions. Humans, there is an even greater number of corticomotor neurons that directly project to alpha motor neuronal pools that control finger function. This is also the reason why if there is a lesion of the upper motor neurons or in the primary motor cortex, it has a devastating effect for humans, but less devastating effects in lower animals. Okay. We will discuss the lesion cases later. So, here we will discuss the work of Peter Strick. What is shown is the set of neurons that innervate the muscle adductor pollicis. Here in this picture abductor pollicis longus, and here in this picture extensor digitorum longus. So, this is about so that distance is about 2 mm. This direction is medial and this direction is rostral. Okay. And note, this is in the specific area that is just rostral to the central sulcus, okay, or just anterior to the central sulcus. Anterior to the central sulcus you have primary motor cortex. Within the primary motor cortex, the most caudal part or the part that is very close to the central sulcus. So, what this shows is that there is a distribution. So, for this muscle, the control or the neurons that control this particular muscle are distributed over a relatively large area, 2 mm. 2 mm is a relatively large area in neuronal terms. So, you see that there is a great amount of distribution, or actually more than 2 mm, a great amount of distribution of neurons that control this particular muscle. Likewise, for a different muscle, see there is a great distribution, and here there is an even greater distribution, right. So, what this means is that there is both divergence and convergence. So, from a particular neuron or from a particular area there may be projections to multiple muscles. Let us call this muscle 2, call this muscle 1, there is, let us take a different color, and I am going to take this muscle 3 and so on and so forth. So, there is an amount of divergence, and there is also convergence, right, in terms of the muscle. So, there is origin of control at multiple sites and convergence is to a particular muscle. So, there is both great divergence and convergence from the neuronal sites to the muscle or the alpha motor neurons that control the muscle in the spinal cord. Okay. So, that is also seen here. For example, here what is shown here is the muscle field of 4 different muscles. So, here is input coming from a cortico motor neuron, and that is branching into 4 branches, and it arborizes into muscle fields of 4 agonists. So, these muscles perform the same mechanical action. So, one corticomotor neuron innervates all of them and simultaneously activates multiple muscles. Okay. So, they perform approximately the same mechanical action. What is not shown in this picture is that through inhibitory interneurons, for example through GABAergic neurons, these corticomotor neurons also inhibit the antagonists. So, let us suppose these are flexors, these 4 muscles. So, I am going to call this 1, 2, 3 and this is the 4th muscle. Let us call these 4, let us assume that these 4 muscles are some flexors, right. The corticomotor neuron also innervates interneurons that inhibit or produces a negative activity on the extensors, thereby releasing the extensors when the flexors want to flex. Input from multiple clusters of corticomotor neurons. So, here are different clusters of corticomotor neurons. They project onto multiple motor neuronal pools of extensors. Okay. So, there is divergence here, and what is also shown is that through inhibitory interneurons here, these are inhibitory interneurons, they also inhibit the activity of the flexors of the antagonists. What is not shown is that these flexors are also receiving inputs from different clusters of corticomotor neurons, that is not shown, and they are also inhibiting the extensors and so on and so forth. Okay. So, what we have learnt is that there is both convergence and divergence from the corticomotor neuronal pools to the spinal motor neuronal pools. Okay. So, in this class, we have discussed the work of Dr. Peter Strick, and so with this we come to the end of this class. So, thank you very much.